have not seen them before. Okay, so do your little summation. Put I equals 1 to n f of x sub I delta x sub I. You did this?
Yeah.
Regular or pre-AP?
Regular.
In regular you did it too?
Yeah.
What? Oh, great. Well, then you'll know some of this. Okay, so then tell me what you know.
So you don't even count.
I mean, it just looks
It's a video. Okay.
Find the numbers for the
Okay, so we're not going to do it with a calculator. But that's great that you remember that because it is a pattern, right? Okay, so delta x sub I, okay, is going to stand for, actually, hold on, let me rewind. Okay, so this is f of x1 delta x1 plus f of x2 delta x2 plus dot dot dot.
This is so fun, but I have a question.
Okay.
What happened to Miss Patterson?
She went to Garland High School.
Oh.
She teaches actually calculus there still. I see her sometimes. We text each other.
Patterson, who's that? She used to be geometry.
She did pre-AP Algebra 2, I think.
Yeah, I said geometry.
Oh. Okay. So I'm going to label some parts for you. So here's kind of what's going on. So your I is called the index. Okay, and your index is going to be integers increasing to the upper boundary. Now, integers are like whole numbers. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now whatever n is, that's your upper boundary. Upper boundary. Okay, then delta x sub I is going to stand for the width of the ith subinterval. And then f of x sub I, okay, I don't know where I'm going to write that. I'm going to do a little arrow thing here. Okay, whoop. Okay, that is going to be your y value. And it is going to be some sort of algebraic formula that you're plugging into. Algebraic formula. Okay? Now, the left side of this is new. The right side of this is a what? That should look familiar to you, this side. Good, the Riemann sum. Okay, and so notice every time the reason it's a Riemann sum is that you have a y value and then a width, and then a y value and then a width. So because it's that same pattern over and over again, okay, you're allowed to use a summation to do that. Okay, so before we actually start with actual integrals, okay, we're going to do just some practice ones to make sure that everybody knows how to work these. So let's say, example, I think we're only going to do 3 of these. Okay, first one, let's go from the summation of 2x plus 1. And let's go as I goes from 1 to 5. So this junk right here is what you're plugging into. And you're going to start at 1. So ready? Plug in 1 to the little formula. What do you get?
2, 3.
Okay, 3 plus. Okay, now I'm going to increase from 1 to 2. So plug in a 2 here. That's now a 4 plus 1 is 5. Now I'm increasing my I to be my third term. So I'm plugging in 3. 2 times 3 is 6 plus 1 is 7. Now I'm on my fourth term. Okay, and then my fifth term would be 2 times 5 is 10 plus 1 is 11. Okay, then you would add those up. What's 3 and 7 together? 10. What's 9 and 11 together? 20, so that'd be 35. You could just add them up however you're comfortable. Yeah, I was just adding up the numbers in pairs that add to 10. Okay, got it? Hard or easy so far? Okay, good. One more like that. Let's do...
You missed the 5.
Yeah, why did you skip 5?
She didn't.
Because 7 and 3 give you 10. 5's just kind of like it doesn't make a 10, so I just waited till the end. But that's just how I add. That's kind of weird. I know nobody else probably really does it like that. But it's fun to add that way, you know.
I got you.
Okay? Okay, next one. I goes from 1 to 3, and we'll do 2x squared minus 5. Okay, how many times are we plugging in numbers? What numbers are we plugging in?
3 times.
1, then 2, then 3. Okay, so plug in 1 to the little formula. Good question, the bottom number. So if I change this to like a 2, then I'd start plugging in at 2. But typically that formula always starts at 1. Okay? So plug in a 1 here, what would I get?
1, 2.
Minus 5 would be negative 3 plus.
4.
Okay, I plugged in 1, now I'm plugging in 2. What's 2 squared?
4.
Times 2 is?
8.
8 minus 5 is?
3.
3 plus. Okay, next I'm plugging in 3. What's 3 squared?
9.
Times 2?
18.
18 minus 5? 13. Okay, now let's say that I change this to a higher number. You would keep going. Because it's 3, I stop there. Got it? Okay, so this number tells you the number of terms in the sum. So if it was 100, God forbid, you'd have to plug in all the numbers till you get to 100, okay, which would be terrible, but we're not going to do that. Okay, so a Riemann sum, as we talked about, is a repeated sum. So you can use summations to shorten that formula. So the integral from a to b of f of x dx is approximated by, okay, a summation as I goes from 1 to n of f of x sub I delta x sub I. And what you're going to have is a series of widths multiplied by y values. Now, we're going to go ahead and identify a couple of things over here. So, delta x sub I is the width of each subinterval. And you are going to find it by figuring out how long b minus a is. And then you're going to divide that by n. And we're going to practice all of this. So I know right now it's kind of confusing. So delta x is b minus a over n. Now, n right here is going to be the number of rectangles that are going to be used in the approximated area. The number of rectangles you're using in the approximated area. Okay, and then x sub I is a plus delta x I. Now, a is where you're starting the integral. So do you see that you have your a here and you have your a here? Those are the same a. So a is where you're starting shading for the area. Okay? Questions so far? Doing okay? Alright. So the first one that we're going to do, may I turn the page? Are we all? Okay, good. Alright. So I would like for you to approximate an integral. Okay, approximate the integral from, let's go 2 to 10 of x plus 1 dx using 4 subintervals. Okay, the first thing that you need to find is how wide each piece is going to be. So, delta x equals b minus a over n. Okay, now, my integral, remember, is from a to b. So what's my a and my b here? 2 and 10. So if I'm shading from 2 to 10, how wide is that? 10 minus 2 is 8. And then I want to divide by n, which is how many rectangles I want. How many rectangles do I want? 4 rectangles. So if it's 8 wide divided into 4 pieces, how wide is each piece? 2. Okay, that's the width. Okay, x sub I is going to be whatever you're starting the shading at and then adding your width, I. So I'm going to write that right here. It's A plus delta x, I. So what is our A here? Where are we starting the shading from? 2 plus, and then what's my width each time? 2I. And then what I'm going to do is I'm going to take that 2 plus 2I, and I'm going to plug it in for my x.
Why did you keep the I?
Okay, that's a good question. Think about, as I want to keep going with my x's, I'm going to add 2 each time. So like I'd start at 2, then I'd add 2, that'd be 4.
Okay.
Then I'd add 2 again, it'd be 6. So that shows I'm going up by 2 each time for my x's. Okay, so this would be approximated by the summation as I goes from 1 to 4. Now remember, 4 is symbolizing how many rectangles I'm breaking my area up into. Okay? Then I'm going to have x plus 1, but instead of x, I'm going to plug in this. 2 plus 2I plus 1. So it's still x plus 1, but I put this stuff right here in right here. And then what did I need to multiply by at the end? Do you remember there was a delta x at the end?
Yes.
What's my delta x here? 2. Okay? Now, we are going to increase I from 1 to 4. So let's do 1 first. Plug in right here. Okay, we're plugging in 1. I is a 1. So that's 2 plus 2 is 4. Plus 1 is 5 times by 2. 10 plus. Now we're going to take I from 1 to 2. We're plugging in 2 right here for I. So 2 times 2 is 4. Plus 1 is 6. Plus 1 is, times 2 is 14. Annoying, but not so bad, right? Okay, now we're on the third term, so we're plugging in a 3. 2 times 3 is
6.
So that makes this an 8.
9.
8 plus 1 is 9 times by 2. Okay, you plug in 4. Don't do it out loud, just do it in your head. Or on your paper if you need to do that. So you're plugging in a 4. Whoop. Right there, this is the last one. So 2 times 4 is 8. That makes it 10. 11 times 2 is 22. Now, think about, could you have done this with a Riemann sum by hand? Sure. Okay, this is a allegedly shorter version of doing that. Allegedly.
Wait. Where did you get the 1 from?
Do you see the plus 1 here? So that was part of my formula. So the 2 plus 2I is my x, and then the plus 1 was already in that formula. Okay? Alright, let's do another one. So that was number 1. If you didn't get that one, okay, let's try another one. Okay, so this time you're going to find the interval from 11 to 20 of e to the x dx using 3 subintervals. Delta x is going to tell you exactly how wide each subinterval is. So delta x is going to be how far I'm shading from 11 to 20. How far is that? 20 minus 11 is 9, but then I'm going to divide it into 3 equal pieces. So it's 9 long divided by 3. How wide is each piece? 3 is my width. My delta, my x sub I, is going to be where I'm starting the shading and then plus 3 each time. When am I going to start shading this time? Look at your boundary. 11. And how much am I going up by each time? 3i. So I'd go up by 3, then I'd go up by 6, then you see what I'm saying? That pattern is going to tell me to keep jumping 3 each time.
Why did you put 11 plus 3i?
11 is the lower boundary. And so if I'm not shading till 11, then I would have to do 11 plus and then count by 3s. Okay? All right, so let's rewrite our integral. So I'd have the summation as I goes from 1 till when? How many rectangles are we using this time? 3. And then I'm going to take this junk right here and I'm going to plug it in for my x. So instead of e to the x, what is it now?
E to
11 plus 3i. And then what do I need to remember to multiply? It was f of x sub I times delta x, which was 3. Okay? Then from there, how many numbers am I going to plug in? 3. 1, 2, and 3, one at a time. Okay, let's do 1 first. Just look at your little exponent. Okay, plug in a 1 first. What would I get? 11 plus 3 is e to the 14 times 3. We already plugged in 1. What are we plugging in next? 2. 2 times 3 is 6. Plus 11 would be e to the 17 times 3. Next one. We're plugging in 3 now. 3 times 3 is 9. Plus 11 is e to the 20 times 3. This is still a Riemann sum. It just looks, in my opinion, way worse, but it's a thing.
Yeah, it looks weird.
Okay? Now, I want you to notice a couple things here. What is 3 still representing? The delta x every single time. And what is your x jumping by up here? 14, 17, 20.
3.
Jumping by 3, because what's the width? 3. Where did I start? At 11, right?
If our delta x is the same, can we not just do like the short way? Can we not just bring it to
We're going to, but so yeah, she's saying, could I take out the 3? Sure, you could if you want to in your notes, okay? Okay, we're going to do one more like this. Okay, we're going to integrate sine x. And we're going to go from 1. I am skipping. I did have 4 examples, but they are kind of annoying, so we're not doing all 4. We're going to use, let's do 4 subintervals. Okay, so first I want you to find delta x. Look back at the formula if you have to. Okay, don't say it out loud. Delta x is b minus a over n, where n is the number of rectangles that you are breaking your area up into. Remember, a is your lower bound, b is your upper bound. So your formula should be 9 minus 1 over 4. 9 minus 1 is 8. 8 divided by 4 is 2. That is your width for each sub-interval. Your x sub I, you are going to start where the shading starts. Where would I have started shading? 1. And what am I going up by each time? 2i.
when you do the sigma thing, after you write your equation, you don't have to put like dx or...
You do not put any kind of ending. You're right. I goes from 1 to how many subintervals this time?
3.
4. Yeah? And then I'm taking my x sub I and I'm plugging it into x in my formula. So instead of sine x, it's going to be the sine of 1 plus 2i. And then from there, you would plug in those numbers ascending 1, 2, 3, 4. Okay, so let's do 1 first. 1 plus 2. Sine of 3. Oops, what did I forget to write?
The 2
Times 2. And what does that 2 come from? That's the width. Okay? So this is my f of x sub I. This is my delta x. And both of those pieces should always be there.
Can you not just do sine of 6?
Okay, that is a good question. You can't do sine of 6. This is why. It's the sine of 3 times a width of 2. So you want to make sure that's not the sine of 6. That's not quite the same, right? The 3 is plugged into the sine, and then you're multiplying by 2 after. Okay, next one. I'm increasing now from 1 to a 2 is my I. This is the second term. What is this? 5, so that'd be the sine of 5 times 2. Okay, next one. Okay, sine of 7 times 2. And then sine of...
Is there always going to be a pattern?
Yeah, there is always going to be a pattern. Good. Okay, and then kind of think about, right, does it make sense I'm jumping by 2, 3, 5, 7, 9? Yeah, because that's my width. Okay?
So do I even have to do the work?
I mean, okay, on the AP test, they would not ask you to figure one of these out like this. But we can't pass it all the way or else you're not going to understand the definition. Okay, so we have one more example, and we're going to do it in 4 parts. Okay, and this is where you might... Isn't it empty, though? That's like you have this empty water bottle. Okay, ready? So we're going to do the same example, but we're going to do it with 3 different numbers of intervals. Okay, so our equation's going to be easy. It's just going to be x squared, I think. Yep, x squared. And we are going to go from 1 until 13. Okay, but first, we're going to use only 2 rectangles. Okay, so find your delta x for me. So delta x would be 13 minus 1. How far are we shading? 12 units divided into 2 pieces, 6 each. X sub I, where am I going to start shading? At 1. How much am I going up by each time? 6i. So it'd be I'm starting the shading at 1, I'm going up by 6 each time. Okay, then I'm going to write my summation. I goes from 1 to 2, because I only have 2 rectangles. And then I'm going to take my xi formula, I'm going to plug it in where my x is here. So instead of x squared times 6, where this is my f of x, and this is my width. Okay? Now, I like your thinking about pulling out the 6, so I'll let us do it here. So, 6 times. Now, how many numbers are going to go in here? How many rectangles? 2. So, 1, 2. Okay, first I'm plugging in 1. Remember, we're ignoring the 6 because we pulled it to the outside. So, 1 plus 6 is 7. Squared is 49. Next, we're plugging in a 2. This is our second rectangle. 6 times 2 is 12, plus 1 is 13. Square it. 169. Good. Okay, now for part B, we're going to increase the number of rectangles to 3. Everything else is going to stay the same, though. So I'm still integrating from 1 to 13. My function is still x squared. Okay, what is going to happen to the width of my subinterval if I increase the number of subintervals? They're each going to get smaller. So delta x equals 13 minus 1 divided into 3 equal parts. Okay, so that would be 12 divided by 3 is 4. Remember, that's my width. Okay? Then from there, my x sub I would be my shade start, which is 1 plus 4i. Very good. Okay, write your summation for me here. I'm going to go from 1 to 3. And then remember, it's f of x sub I times delta x. So my x sub I is plugging in. It's 1 plus 4i squared times 4, where 4 is your width. How many numbers are we plugging in? 3. So we're going to shortcut. Go ahead and pull that 4 out. 1, 2, 3. Let's plug in 1 first. Okay, that'd still be a 4. 1 plus 4 is 5. 5 squared is 25. Plus
4 times 2 is 8, 9, 81.
9 squared is 81. Okay, next I'm plugging in. This is my third one, so that'd be 12 plus 1 is 13. 169. Okay, we're going to do one more, and then we're not going to keep doing this. Okay, so part C. Use n equals 6 subintervals. Now think about, as I make more and more subintervals, your width should be getting tighter each time. It should be getting smaller. So my delta x is going to be 13 minus 1, still 12 units long, but I'm dividing into 6 pieces. How long is each piece? 2. My x sub I, I'm still starting the shading at 1, but I'm increasing by 2 each time. Okay, so summation, I starts from 1 till 6, and then I would have 1 plus 2i squared times 2. Okay, let's go ahead and pull the 2 out since everybody's going to have a 2. And we're going to be plugging in 6 different numbers here starting at 1. So 1 plus 2 is 3, squared is 9. We're going from 1 now to the second term. I is a 2. 2 times 2 is 4, plus 1 is 5. What's 5 squared? Okay, next one. We're plugging in a 3. That makes that a 6 plus 1.
49.
Okay, 7 squared is 49. Now we're on 4. That makes that an 8 plus 1 is 9 squared is 81. And if you ever lose count, look, watch. 1, 2, 3, 4. What's next?
5.
Plugging in 5. That'd be 10 plus 1 is 11, so that's 121. And then my last one would be my 6th one. So 6 times 2 is 12, plus 1 is 13, so 169. Okay, now, without adding all of these up, because that would be a waste of your time, okay, any guesses at what you think happens to the number as we make the subintervals smaller?
The number gets bigger. Or like the answer gets like
squared.
Huh?
What are you asking?
If I were to add all of these up, this one, and this one,
They'd be equal. Yeah.
they're not going to be equal. Let's go to your pink sheet and we're going to discover what happens. Okay, you can't wait, I know. Now, obviously, I can't do x squared out to 13 or else your chart would be too huge. But I want you to break up your area into 2 subintervals. We're just going to go from 0 to 4. So if I wanted to cut that in half, 0 to 4, I'd have delta x would be 4 minus 0 over 2. How wide is each one? Okay, so break it up. Here's 2. Here's 4. And let's just do a right Riemann sum.
How do you know you did 2 and 4? How do you know where to break it up?
So I'm integrating from 0 to 4.
Yeah.
And so I did 4, remember b minus a over 2?
It's 2.
Uh-huh. So that's why I went 2, 4. So my width is 2. Does that make sense? My delta x is 2. And then I'd cut this one across here. Okay? So look at your area of those boxes. That would be your answer. Okay, let's go down to 4 subintervals. If I integrate from 0 to 4, and I want 4 subintervals, my delta x would be 4 minus 0 over 4. My delta x this time is going to be 1. So break your graph up into 1 width boxes.
So just one big box?
Well, so a width of 1 would be 1, 2, 3, 4. Okay, it doesn't have to be perfect.
Right or left?
I'm using right. But the same thing would happen regardless of which one you use. Okay, now how many intervals are we using on the bottom one?
3.
What does it say?
8.
Use 8. So I do 4 minus 0 divided by 8. Each one is going to be a half. Now notice on your little chart, I gave you the halves on there. So I'm going 0.5, 1, 1.5, 2, 2.5, 3. The confusion will hopefully end soon. Yeah, we're figuring out.
I see that too, but I still don't get it. Half, 1, half. I get it, kind of. 3, 4. I'm not drawing a line.
Yeah.
Can you go on the room?
Sure.
Yeah, my boxes do not look like that. Yeah.
Okay.
Like connected all the way to the origin. It's
Mine
like
don't use
this.
Oh no.
All of mine go to the origin.
Yeah, no, remember that's just remember you're approximating the area? Y'all's boxes are on crack. So it'd be like that. That, yeah?
I feel like you just whipped in the face, that's why.
Yeah.
Alright.
Hold on. That doesn't sound right. Hold on.
What do you mean I went to the origin?
Like I
She connected her boxes like all the way across.
Dude.
You did? Okay. Okay, so here's the question. This is why I made you even draw these boxes to begin with. What do you notice happens to the error as you increase the number of boxes? So when I say error, if you're not familiar with that, I mean how far the area is off by from the actual area. So on my first one, how much area am I missing? All that is way too big, all that is way too big. Okay, then what happens here?
As you go higher up, you're more exact.
Yes. Okay?
That way you would.
Yes.
Okay.
Okay, now look at the next one. What happens? My error last time was all the way across. Now I have a little bit less.
Yeah.
And then as I break up even smaller, I have even a little bit less than that. So as the number... What? Wow, yes. So as the number of boxes that you make increases, your accuracy gets better. Now, what happens to the width as your boxes get to be more?
Yeah.
Gets smaller. Okay, so we're going to basically write all that out. Look, you discovered it. Good job. Okay? So,
That's my 18
as the number of subintervals increases, okay, and if you want to put a number of subintervals, that's your n. So as your number of subintervals increases, your estimation becomes more accurate each time. As the number of subintervals increases, the estimation becomes more and more accurate each time. Now, what are we estimating? We're estimating an area, yeah? Okay, so here's your definition of an integral, which is like the whole point that we did any of this. Okay, the integral from a to b of f of x dx is exactly equal to, not approximated by, that big long formula crap that I gave you, but with a limit as n goes to infinity.
Hold on.
Okay?
Limits.
So do this thing, I from 1 to n, and then remember it's f of x sub I delta x. But then we're going to put a limit in front of it so that your n goes to infinity. That's the exact definition of an integral. Now, guess what? On Friday, I'm going to teach you a shortcut to find these, so you never have to do this again. But it is on the AP test, so turn your pink sheet over, and you'll notice 5 little practice problems that we're going to do together. Okay?
I thought we could learn all the other stuff.
Okay, so ready? But look, you've already done most of the hard work. Okay, so look at the first one. Okay, I even broke it up for you a little bit. So, first question, it says you have your function, this is ln x, okay, hi ln x, there it is. Okay, then it says write an integral expression to represent the shaded area. Where did they start shading on my graph?
1 to 4.
1, and they stopped at 4. So this is the integral from 1 to 4 of ln x dx. 1 to 4.
Wait, you forgot to put the parentheses. No, the thing. The bar.
Absolute value.
Yeah.
That's the pen and bring it.
Yeah, and okay, so you don't need bars on this. That's if you integrate 1 over x. But you're right, those are in that formula. Okay, so we're going to now discover, like on the AP test, this is how they'd phrase it. They'd say which of these is equal to that area. So you'd write it as an integral, and now we're going to convert into that limit crap. You don't actually have to figure it out, but we're going to convert. So first I find delta x. B minus a over n. What is my a to b that I'm integrating from? 1 to 4. So it'd be 4 minus 1 over n. Can I simplify that? What is 4 minus 1? 3 over n. So look at your multiple choice answers. Which of those does not have a 3 over n multiplied at the end?
C and D.
Okay, so C has a 4 over n. We don't want that. That has a 4 over n. We don't want that. So 3 over n check. 3 over n check. Okay, the other thing we have to check is our x sub I. X sub I, you are going to start where you shaded. Where did they start shading? 1 plus, and then what are we going up by each time? 3n. Now notice, why isn't it an exact number? Because we're leaving n as a generic for however many rectangles we want. Okay, so what would I do with that? Where would it go in the equation? Inside the ln. So do I want this one or do I want this one? I want B. Do you see?
Yeah.
Not so bad?
Not so bad.
Great. Okay, look at number 2.
Wait, so K is I.
Okay, yes. Now, on the AP test, they'll usually use I or K. They do the exact same thing. So if it's an I or a K, notice they used a K down here. Okay, but a lot of times they'll use I. Sometimes they'll use J. So don't pay attention to that letter. Just know they're going to pick whatever letter they want.
Why is A wrong?
Do you see how the 1 isn't plugged in with the ln? It should be the ln of 1 plus 3 over ni. And do you see how their 1's kind of just outside the ln? It should be in there with where the x was. Okay, so do the first 2 steps on this next one. Find me your delta x, and then find me your x sub I. Where am I integrating from on the second question? From what to what? 2 to 5. So I do 5 minus 2 over n. What's 5 minus 2 over n? 3 over n. Which one does not have a 3 over n? A and B has a 1 over n. Do you see that's not right? Okay, and then C does have a 3 over n, but do you see how they kind of awkwardly put it in the front? Okay, that's actually allowed. They can put it inside or in the front. It doesn't matter. Okay, the next thing would be my x sub I. Where am I starting the integral from? 2. What am I going up by each time? 3ni. And then what would I plug that in for in the equation? The x squared. So it would be this crap right here and then a squared on it. So which of those is correct? C or D? D. Because see how this one doesn't have the 3 right here? Okay, it should have had a 3 next to the I. Okay, now going backwards is a little bit harder, but let's look for some key things that we can use to help. The first one is the width. What is the width here? 6 over n. So which of those are not 6 wide from A to B?
C.
0 to 6, check. 0 to 6, check. 1 to 10, how far is that? 9. We don't want that. And then from 1 to 7, does that count as a 6 width? Okay, yes. Next question, where did they start integrating from on the x sub I? Look at this chunk right here. They started integrating at 1. So which one would I have to pick? D.
Oh, yeah.
Because your x sub I, remember, okay, x sub I is a plus delta x I. So if my a is a 1, I need to make sure that bottom limit matches. Okay? All right, check the next one. How wide should my interval be? 2 pi. Very good. My delta x needs to be 2 pi over n. That means that my a to b has to span a width of 2 pi units. So from pi to 3 pi, is that 2 pi?
Yeah.
Yes. 0 to 2 pi is good?
Yeah.
0 to 2 pi is good. What about that one?
No.
0 to pi is too short. They didn't go far enough. The second thing that I should be looking for is what my a is. Did they add anything in front of this?
0.
No, then where did I start integrating from?
0.
Has to be 0. Does anybody not understand why that is? Okay, your x of I should have an a with it. If it doesn't, that means it's 0 plus that crap. So you know they started shading at 0. So that eliminates a. Okay, last two left. Should there be an extra pi in here or no? No. Where did the pi come from? The delta x, right? So if they already had a pi in there, it would have been a pi squared. And we know that that's not the case because we can see the integral. Okay, last one. I don't know what was going on with this g thing that happened. But just kind of pretend that's not there. I typoed something wrong. Okay, so how wide should my interval be?
5.
Okay, look right here. You see the 5 over n? So are any choices eliminated with that?
No.
Okay, no. What should I be starting my integral at?
4.
You see the 4 every time? So I would be integrating from 4 and up. Which ones does that eliminate? C and D. Okay? And then the next question, should I also have a 4 plus on the inside? Or is the 4 plus part of where I'm integrating from? It's where you're integrating from. So should it be A or B?
A.
Should be A. Okay, one more time. This is why. Because where does the 4 in this come from? That's your A in your x sub I. Remember, it's A plus delta xi. So this is where you're starting the integral from. That's why there's a 4 there. Okay, if that confused the ever-loving whatever out of you, you may have like 2 of those on the whole AP test. So if you're going to be bad at something, maybe pick that and just we'll move on with our lives, okay? But good job.
Are we done?
Yeah, you don't have any homework.